All right. So,
Hey, Brandon.
ellipses. Hey, Brandon.
I'm gonna have so much more.
Huh?
Not so much.
Hi, Brandon.
It's bad. Not for your class, just any other class.
Oh, I think a lot of other classes are doing cameras and stuff. I mean, he Skypes in some of classes. So, all right, ellipses. Here we are. Okay. So I'm going to go ahead and go over this again. I mean, much clearer this time around, and we're just going to concentrate on ellipses. Okay. So, okay. Just as a reminder, basically, this is an ellipse, and this is all the parts of it that are labeled. Okay. Why is it doing that? There we go. Okay. So, you're right for you. Okay. So, here's an ellipse, and here are all the pieces of it, basically, to remind you, okay? An ellipse is basically an oval shape. You can think of it as being like a flat circle, or a circle that's been elongated. A way I like to think of it is a football is actually is basically the shape of an ellipse, okay? Now, American footballs, they're a little pointed on the ends, so they're not quite as good examples of ellipses, because an ellipse would be pointed and be more round on this end. Okay.
Like a rugby ball.
Rugby ball and Australian rules footballs is basically an ellipse. Okay. So, yeah, that's basically shape-wise what we're dealing with here. Okay. But basically, here we have it. My best drawing of it. They have some features in common with circles and some features in common with parabola. Okay. For example, they've got a center, just like a circle does, okay? And they've got this round edge, like a circle. However, they've got pieces that are more in common with parabola, like they've got vertices wherever the axes cross the circumference. They also have two focuses, one on either side of the center along what's called the major axis, okay? And that's the thing, too. Because these aren't perfectly round, because these aren't like circles, okay, instead of having radius, these things have a major axis and a minor axis, okay? Major axis is just the big one, the minor axis is the little one. And they're typically marked as A and B, so A is the major, B is the minor, okay? So on and so forth. But there you have it. Those are all the pieces of an ellipse, okay? The final property that an ellipse has is they've got something new that we'll measure called eccentricity, okay? All the eccentricity is basically a measurement for how flat the ellipse is. That is, so basically that is how elongated and squished basically this thing is, okay? Eccentricity is always a value between 0 and 1. The closer you are to 0, the more like a circle your ellipse is, and the closer you are to 1, the more elongated and flat your ellipse is. Okay? So, in fact, actually, eccentricity exists also for parabolas and circles. The thing is, we don't care about it so much because for the circle, the eccentricity is always 0. There's no flatness, basically. And for a parabola, it's actually always 1. It's so flat, we're no longer an ellipse, and we're this U shape instead. Okay? Everyone got that? All right, good. All right. Moving on then.
Just real quick.
Yep.
Could you have an ellipse so flat that it becomes a line?
Yeah, it's called a parabola. Okay.
Well, why wouldn't it be a straight line instead?
That's a good question. Basically, it can be a straight line. In fact, you could think of a straight line as being a parabola that's just really, really stretched out. Okay. So an ellipse that is really flat can be thought of as just as a parabola that's been really stretched out. Okay. Which kind of in a way it is. Okay. But that's basically how you do that. In fact, actually, one definition for a parabola is that a parabola is an ellipse that's just infinitely long in a direction. So it's so long it never comes back on the opposite end to reconnect. Which is kind of the way things are. Any questions here about the basic terminology? All right, moving on. Okay, so here's the equation for an ellipse. It's suspiciously like a circle equation, but with some extra features. Okay, basically, it's got the minus h and the minus k are still present, and they represent the center, found the same way you find it for circles. So the opposite of h, the opposite of k, is your center. Okay. The big difference is you're going to divide the x's and the y's by a and b, okay, squared. Those are the numbers for your axis, okay? So notice how it's squared, and so your axis might be 3, so here it would be 9, okay? My axis was like 10, and here it would be 100, okay? Everyone got that idea? All right, good. So for a horizontal ellipse, the major axis is always going to be under x. For a vertical ellipse, the major axis is under y. Okay, so that's the way to tell whether I'm an ellipse in this direction or in this direction. Okay, basically whether the football is football again. Whether the football is like this. Okay, this would be horizontal. Football is like this. That's vertical. Okay, everyone got that? So horizontal ellipse, vertical ellipse. Okay? Thank you, Mr. Football. It's a Mr. Football. Alright, equation for ellipse. There you have it, okay? And so that allows us to be able to figure out everything. So if I'm giving a random equation for an ellipse, and we're going to do this in a second here, you're able to pick out all the pertinent information and then graph the ellipse from that information basically by just knowing what the pieces of this equation are, okay? One final thing, notice how in both these equations it's equal to 1. Ellipses always are equal to 1, okay? So unlike a circle where that's going to be where the radius is and we're just equal to that, or where the radius squared is, for an ellipse, it's always a 1. If that number is not a 1, then we do not have an ellipse, we have something else, okay? Something much nastier. It's neither a circle nor an ellipse, okay? All right. 2 final equations that are useful to know. First one's the equation for finding the focus, okay? And the second one is the equation for finding eccentricity, okay? The focus equation is pretty easy. It's going to be the focus, C, is equal to the square root of a squared minus b squared. That is, you take a squared, subtract b squared from it, and then take the square root of all that. So that gives you the focus. Now what the focus is actually, or what this number is going to be here, is the distance away from the center you are, or it gives you the distance away the focus is from the center on the major axis. Okay? So, basically, to find out the equations for a focus, I would basically take the C and then add it to my center. So, for a horizontal ellipse, okay, the focus location, okay, would be at H plus or minus C, okay? And for vertical, okay, the focus is at H, K plus or minus C, okay? Okay, everyone got that? So the actual coordinates of the focus are found this way, okay? So the C you find when you do this is just telling you, again, how far away I am from the origin, okay? Yeah?
How do you know if it's plus or minus?
Oh, it's always plus or minus. Because there's 2 focuses, one on either side of the center, okay? So unlike a parabola, which had just 1 focus, this one has 2 foci, actually. Foci is the proper focus. F-O-C-I. Okay. Any questions there? I don't like saying the word foci because it always sounds like I'm poorly cursing. Anyway. Or trying to say something crazy different. Alright. Anyway, there you have it, okay? Now, the last measurement is that eccentricity. Eccentricity is easy. The number for the eccentricity E is equal to whatever number you found for C divided by the major axis, okay? A, okay? So if C was like √5 and A was 3, √5/3 would be the eccentricity, okay? Any questions there? All right, good. Okay, moving right on. Let's take a look at our first example here. And I'm actually going to go ahead and clear all this away, and we're just going to redo it all. Okay? I'm going to keep the equation though. Yeah. So, my equation. Okay. So here's an example. Okay. What we want to do is we want to find. Actually, we want to graph the ellipse given by this equation here. Okay. X plus 5 squared over 4, and then y minus 2 squared over 9 equals 1. Okay? Alright, yeah?
Does A and B equal the length of the axis?
Yes. Okay? Or rather, length from origin to end. Okay? So when I graph it, you'll see exactly the length we're dealing with. Okay? So
when we distance from point to point rather than point to
the center, yeah.
center.
So, and remember, these are squared here, so it's not like one's 9, the other one's 4. It would be like
One's 3 and
one's 3 and one's 2. Okay.
Wait, A and B are squared?
Yeah, in this equation up here. Okay. In the previous one, okay. So basically, see how they're squared here? Okay. They're squared in the equation, but the actual number you want is going to be the square root of that, basically. Okay. Next. All right. So, very first thing we'll do is we'll find the center. What's the center going to be? -5, 2. Okay. Good. Again, find the same way for circles. You just do the flip of whatever those are. Okay. Next, we've got the major axis and the minor axis. What's the major axis going to be?
3.
Be 3, and the minor one will be 2. Now, is this vertical or horizontal?
Vertical.
It's vertical. How do I know it's vertical?
Because the major axis is under the y.
Major axis is underneath the y coordinate. That needs to be vertical. Okay, good. Now, the next two things we're going to figure out, we want to know where the focuses are. Okay? So, the focus number, we're just going to write it as C. Okay? What's C going to be equal to?
Square root of
A minus 2.
It's a squared minus b squared. So it's actually just the square root of 9 minus 4. Okay? Square root of 9 minus 4 would be √5. So my foci, okay, are going to be at -5, 2 plus √5, and -5, 2 minus √5. Okay, those would be the foci. All right. Last thing I could possibly ask you about this thing is its eccentricity. I'm gonna clean that line up here real fast. Sorry. I want these to look very neat, nice and red. There we go. All right. Now, final thing. Okay, we're going to look for, all right, is basically going to be the eccentricity. Okay, and that's found by dividing the number you found for C by the major axis. So the eccentricity E is going to be √5 divided by 3, okay, which is approximately equal to 0.74